Hello, everybody, and we're getting all set up here. Welcome to Hoot, episode 4. Today, we are going to be talking about AWS App Mesh. 1 second, just got to get the right tab. And if cool. Like I said, welcome to Hoot, the series about getting to know service mesh. I'm Eitan Yarmush. I'm one of the developers here at solo.io, and I'm here to talk about AWS App Mesh. In previous episodes, we discussed Istio with Christian Posta, Linkerd with Rick Ducat, and Consul with Yuval Kochavi. And so in such a series, I'm gonna give a quick unboxing of AWS App Mesh and its features, as well as what makes it special and a good contender in the market. So with that in mind, let's jump right in. So AWS App Mesh is really the main vendor mesh on the market right now, and in that way, it's able to integrate very closely with other AWS services, which can be very nice if you're already running workloads on EC2, ECS, if you're using other services such as CloudWatch or X-Ray for observability, as well as integrating with AWS Outposts for on-prem. And with that said, it's actually the first. It's really built from the ground up to work in non-Kubernetes environments. So as I mentioned earlier, with ECS and EC2, and that is a big pro. And as well as AWS Fargate, which is the newest offering from Amazon in this regard, which is more of a serverless Kubernetes offering. And so if we just quickly look here, just to skim the docs, as I said, you can use it with any other services, and it's built on top of Envoy, similar to Istio. It uses a sidecar model, just like Istio and Linkerd, but it uses the Envoy proxy just like Istio. However, the Envoy proxy, as well as the mesh itself, is not open source as of this moment. So we don't know exactly the proxy that they are running, just that it is Envoy. So if we look quickly at their architecture diagram, we see that the AWS App Mesh, what separates App Mesh from some of the other meshes is traditionally you have, in a Kubernetes native service mesh, there is the data plane, which consists of all of the containers and their sidecars. But then there is the control plane, which in Istio's case is like Pilot and Citadel and other components. And Linkerd has the routing and the policy also. But in the case of App Mesh, the control plane actually does not live in Kubernetes, but rather lives in a centralized location. So to interact with AWS App Mesh, you actually need to make API calls to Amazon. So in that way, right, it does not actually live in your cluster, but as I said earlier, it allows you to add non-Kubernetes workloads to the mesh more easily. As it says here, so these little orange boxes representing the sidecar proxies, the Envoy instances, and App Mesh running essentially. So yeah, if we look at features really quick, yeah, open source, visibility, traffic control. So in terms of their traffic control features, App Mesh allows you to do the canary style routing, and I'm gonna show that here in a minute, as well as retries and some other basic traffic management policies. And it's worth saying that it's fully managed by AWS. So actually using their mesh features is completely free if you already are using AWS. So with that, I think we're going to jump right into a demo. And to do that, the demo that I'm following, so you can check it out at home, is this one. There's the link right there. I'll leave that up for a few seconds while I just talk about it. So App Mesh, as I said earlier, runs within Amazon. It doesn't actually run in cluster. So to configure it requires communicating with the AWS API. So originally, if you wanted to configure App Mesh, you either had to do it through the API or through the web console, which I have up here. This will be populated later. We will get back to that. However, they recently created a controller to translate CRDs into their API objects, which is very useful, as well as a sidecar injector. So I said earlier that AWS is a proxy that operates using Envoy sidecars, and originally you had to inject them yourself, but they have created a sidecar injector to do that for you. However, I think it is worth pointing out that they have a very good doc here, once again, in the documentation, EKS getting started with AWS App Mesh and Kubernetes. They have a fairly extensive doc on how to add, how to manually add how to manually add a sidecar to your pods, and just show exactly what's happening, and what all of the different environment variables do, and to get more comfortable with the changes that the sidecar injector is actually making, as well as bootstrap the App Mesh environment from the ground without the help of the controller and the sidecar injector, which I wouldn't recommend for normal workflows, but as a tutorial, I think it is quite useful. The other thing to point out is that this tutorial assumes that you already have EKS running with App Mesh access. And so to do that, I actually used EKS CTL. So you can download EKS CTL right here, EKS CTL. It's a Weaveworks product. You can do it using Brew, super simple, and it allows you to bootstrap EKS clusters very, very quickly. So as I said earlier, your you're really able to run AWS App Mesh on any App Mesh workload. But however, for this unboxing, I have chosen to do it on EKS because that's the environment that here at Solo we work with the most and is definitely the most popular for the service mesh. And so, yeah, like I said, I installed with EKSCTL. For anyone who's curious about what command I used, this is the one. The important thing here is the app mesh access as well as the version. It has to be greater than 1.12. And the app mesh access allows the workloads to actually access the app mesh API from AWS. So unfortunately, this cluster creation takes about 20 minutes. So I ran it beforehand. So with that, we'll just jump right in. So if I go ahead and get my pods running in all namespaces, I do not have much running, just the standard AWS node, core DNS, and kube proxy. So now that that's all done, I'm going to go ahead and try out App Mesh with the controller. So, oh, it looks like it needs to be 1.11 or later. So I have that running 1.13. I have kubectl and I have JQ and OpenSSL. Cool. So the first thing it wants us to do is create the controller that I talked about earlier and initialize the custom resource definitions. So I'm just going to go ahead and do that. Cool. So as we see, it created our new custom resource definitions as well as the controller and the roles and the bindings that it needs to run said controller. And the App Mesh system, which it seems is where it put the controller. So if we now do a kubectl get pods on App Mesh system, we see that we have the controller running. Awesome. Now, if we also go ahead and get all of our CRDs, we see that we now have 3 CRDs: meshes, virtual nodes, and virtual services. Now, these are the 3 main resources that App Mesh uses to configure routing and other traffic management. So now so we can confirm that this is correct. Let's run this command. And successfully rolled out. Good. We already got the CRDs. And now, as I said earlier, we need to install the sidecar injector. And so this is where the actual mesh comes into play. So that's this console that I was showing earlier. So the first thing that we're going to create is the mesh. So in the command line, I'm going to set my mesh name to, let's do my mesh just for the sake of it. So that's my mesh name. And the region for this tutorial is going to be US East 2. So we're going to export mesh region equals US East 2. Oops, not use US East 2. And now we're going to go ahead and install the sidecar injector. Cool. Now that's just waiting for the injector to finish deploying, and there you go. Cool. So now if we get pods again in the App Mesh system namespace, we should see that there are now 2 pods running. There's the controller and the injector. So the injector, as I said earlier, is going to it's a mutating webhook, mutating admission webhook that is going to capture all pod scheduling requests and add the containers that App Mesh needs to intercept all the traffic. So it adds the proxy as well as running an init container, which changes some of the networking and allows all of the network traffic to be captured by the Envoy proxy. So with that done, we can actually configure App Mesh. So first step is going to be creating the mesh. So I'm just going to copy the mesh CRD in here, and it does not tell me where to put it. So I'm just going to assume that App Mesh system, no. Oh, it might be a global resource. So we're just going to copy and we're going to create this guy. So we can just, on Mac, it'd be a pb paste and pipe that into kubectl apply -f. And my mesh was created successfully. Now, let's see how we can verify that happened. Typically, with Kubernetes resources, you can do a get on them, and there might be a status updated or something like that. So let's just go ahead and do that. And mesh condition, the mesh is active according to the status. That's good news. So let's go into the console, refresh, boom, there we go. We have my mesh. Okay, now, as I said earlier, this mesh doesn't have any resources on it yet. So the three main resources are the virtual services, virtual routers, and the virtual nodes. And so we have only created the mesh resource. So the purpose of the controller is to sync the resources, the custom resources that you're writing into Kubernetes with the AWS API, and that's working seamlessly so far. So let's continue with the tutorial. Let's just go ahead and do this. So it looks like it wants you to create a virtual service. And so we don't have any services yet, so I'm not 100% sure this will work. In the next part of the tutorial, it actually has you create the services. I just want to see if I can hide my, this guy here. It's taking up a lot of space. Nope, that's not what I wanted. Well, anyway, so let's go ahead and try this. If we create a namespace for it, let's say kubectl create namespace App Mesh app. And we're going to go ahead. Actually, this unfortunately will not save properly because the namespace is set incorrectly. So if we just open up Visual Studio, make a new window here. Make a new, let's just open up this guy, open up a new window, drag it out. Let's see, where did that go? Can we drag this out? No, it doesn't seem to want to do that. So let's just open that up in here. And so we're going to paste that into here. And then we're going to go ahead and change this namespace to App Mesh app. We don't need to save that. Cool. And now we're just going to go ahead and apply that as well. Awesome. And so now if we go back into the console, that should have been created for us in the virtual services. No, well then there might be an error. Let's go see. So get or kubectl get virtual services -n app mesh app in YAML. So we can take a look at that status, and there is no status on it. That makes sense that it wouldn't have worked because there's no router for it. It's pointing to something that doesn't exist. So interesting that it wants you to do it like that. So if we just continue looking, I think this is more of a, this is just kind of to show you what it can do. And so now what we're going to do is just go to the next part of the tutorial, which is deploying the actual service or app to get injected by App Mesh. And so we can actually handle all of the routing. So let's go ahead and do that. So we're going to delete this virtual service by doing kubectl delete namespace App Mesh app. That should go ahead and delete the virtual services. So now we're going to deploy the sample app, and that will actually go ahead and create it. So we have done all of the prerequisites. So let's go ahead and see everything that this is going to apply, because it's going to apply a mesh. So if we go, we can just copy and paste that. It looks like it's going to create a namespace for us called App Mesh Demo, which has the webhook injector enabled. So this label is going to tell the sidecar injector to inject any pods in this namespace. We're going to create a mesh. We're going to create a virtual node, which is how essentially the virtual nodes are representative of the actual of the workload of the workload as a service. So how a given workload is exposed via service discovery, as well as the backends that it is able to talk to. So the servers that this workload is able to communicate with. And so we have one of those for our color gateway, our color teller, and as well as our specific colors. And so we're just going to go ahead and apply this, and we can look more into it once it is running in our cluster. So we're going to copy that, and we're going to go ahead and paste that and let it run. Cool. So now if we go ahead and get namespaces, we see that we have an App Mesh demo namespace running now. So if we do kubectl get pods -n App Mesh demo, we have 6 pods. And if you notice here, each one of these has ready 2 of 2. So the second pod, the second container running in each of these pods is the Envoy proxy container, which allows, which actually handles all of the inter-mesh routing, so that it looks like the injection happened properly. So now we can see, it looks like a get all will show us everything, including the custom resources, hopefully, and it did. And so we see that there are all those pods, as well as services for each of our pods. And more importantly, here is our App Mesh resources. So we have 2 things. The mesh, my mesh, is actually a leftover from the first part, but the color mesh is the one that was applied here, as well as a virtual node for each workload, and virtual services, which allows them, which handles the routing rules. So if we go back into our console here, into meshes, we reload this, we see there's now this newly created color mesh. Looks good there. And if we go to virtual services, we see, or virtual routers, sorry, virtual nodes, we have our 6 virtual nodes. So each one of these represents, representing a unique mesh workload. Here they are. We can see that they have unique DNS names, which correspond to their Kubernetes service names. You can tell from the namespace dot service cluster local paradigm, as well as here the gateway is able to communicate with two of the other nodes. And then if we look here at virtual services, we can see that this is actually what handles the routing and sets up weights. And so we'll get to that. We'll look further into that in a second. So now, let's run this guy. Cool. We need to, I understand. So we need curl in the, we need to be able to curl from within the cluster. And so this is what is going to allow us to do that. So we're going to quickly run that. It looks like it's going to create us a pod, most likely one that is injected in the App Mesh demo namespace, and that has curl running. So that worked. So now what we're going to do is we're going to ping the color gateway 9080/color endpoint. And if we go ahead and look at our App Mesh configuration, we have our virtual nodes, and our virtual nodes, as we see here, have the one that we are actually going to hit is the App Mesh demo. And when we reach out to the App Mesh demo, sorry, give me 1 second. It is then calling the /color route, which is going to route to our virtual service here, the color teller, which will return either blue, black. Yeah. So let's go ahead and run that command. Oh no, that's not good. What happened here? Let's go ahead and find out. Strange. Okay, let's see. Everything looks good up to this point. Unfortunately, it looks like we're going to have to do a bit of debugging, which is always the fun part. So I wonder, it seems like we could not connect to the gateway on port 9080. I am guessing that our current pod is not injected for some reason or another. Let's see if we can go look at it. kubectl, get pods, app mesh demo. Curler, as we can see, it is running in the namespace, but it is not in fact injected. And so it looks like this demo is not, it does not, it unfortunately does not add that to the pod by default. So I'm wondering if I can, and I cannot delete the pod as it was scheduled alone. There is no replica set for it. So I might have to quickly go ahead and create a deployment for it. If I make sure just to get the replica sets. There is one. Oh, so let's go ahead and look at the deployment. It looks like we may have gotten lucky and be able to just delete it. Or we could just delete the pod and have it be rescheduled. Yes, that looks like the case. So if we just go ahead and delete the pod, we're going to delete it. It's called curler. And when that gets reinitialized, it should have the proxy running in it, and it does not. So I thought that I was under the impression that the namespace being labeled would handle that for us. But let's dig further. So let's get the namespace. App Mesh demo -YAML. And it looks like we have the sidecar injector enabled there. So I'm wondering why this particular deployment does not want to be injected. So let's see. If we look at the deployment, it has some, it does not have any unique labels aside from run. So let's look at the other deployments and see if they have unique labels. Color gateway, let's say. It does not, in fact, have any special labels. So this is very confusing to me. Let's see if we can edit the deployment for the curler, take away that run label, and maybe it will work then. No, not color gateway. I apologize for this again. I am not too sure what is happening. We're going to go ahead and get the pods in App Mesh demo again. And when we edited the curler deployment, it should have deleted the pod, but we'll try again. Well, I am not sure what's happening. This is unfortunate. All right, let's, I'm going to quickly create a new deployment from this guy and see if we can get this going quickly, because I don't want to spend too much time on this. All right, let's grab this quickly. Get over to our handy editor over here. We're going to delete our deployment for that curler. And then we're going to go ahead and we're going to get rid of most of this stuff as we don't need it for now. We can keep that. Actually, we can keep that. We're going to get rid of run. We're going to get rid of our match, or no, we do not want to get rid of that. Sorry. We don't need any of these. We don't need any of these. I'm hoping that because this was created in a slightly strange way using that command, this will alleviate the problem, but maybe not. So we're going to copy that and apply it into our App Mesh demo namespace. Now, if we get pods again in our App Mesh demo namespace, it is still not getting injected. So let's look at our injector. It's fine. I am at a loss. Unfortunately, the lights have just turned out. There we go. I am at a loss for what is happening here. I forgot to, yeah. All right, well, I have an idea. I do have an idea of how we can get around this. I have another pod I know we can deploy. So let's go ahead and do that. Let me go find it really quickly. No. Let me see if I have it in my recent history. I believe I might. Here it is actually. So that was lucky. So we're going to apply we're going to apply into the App Mesh demo namespace this pod, which I happen to know has curl in it. Okay. All right, so no, what? There must be something that we are in fact missing from the docs. So let's go ahead and read this quickly. Very strange. It does not seem to be injecting anymore. Well, this is not a great way for this demo to go. But let's see one more thing. See if we can diagnose the problem one more time. So unfortunately, interesting. So it says no ports specified for injection, doing nothing. So it seems like it is in fact ours. And so it looks like there needs to be in the deployment a port specified to be injected. Let's see how we can make that happen. So it looks like if we go ahead and check the ports on the color, let's go ahead and check the color gateway. It looks like it has a server port env. As well as a container port specified. Let's see if the same can be said for the sleep pod. And it seems it does not have any ports. So, and I'm guessing it would be the same for our curler. So yes, so if we go ahead and let's just quickly add a port, because we know that that is going to fix our issue temporarily. Let's go ahead and just copy this guy. That's fine. And hopefully this will allow us to simply move to the next part of the demo, because we are running low on time now. So now if I just paste this, nope. See where ports ends up in the, it is a child of containers. That makes sense. So we're going to go ahead, put that here. Oops. Sorry, right here. And we're going to go ahead, copy that in, paste, apply. Now we're going to get our pods. And there you go. Okay, successfully debugged. It turns out the App Mesh injector will not inject a pod without a specified port. So now let's go ahead, exec into the pod, try and finish off the demo. So now we're going to run kubectl exec -n app mesh demo deployments /curler -it /bin/sh. Now if we run curl, it is available. Awesome. So let's try and see if this works now. Oops. Failed to connect. Well, with that, I would say that I am officially out of ideas, and it looks like the documentation on AWS App Mesh is a little bit out of date. But I hope that I was able to show off some of the features. Let's just see. I bet I know the problem. So yes, the problem is that the problem is that by default, the app is only allowed to route to known entities, and our curler is actually not a known entity. So I'm guessing we would have to add I'm guessing that we would actually have to add a virtual node as well as backends to our curler to be able to route to the color gateway, which I'm surprised is not a part of the demo because that seems fairly obvious. Let's see what so it seems like that is supposed to work from the get-go, which is confusing to me. I'm wondering if there is in fact a way that we can configure the mesh to be more lenient with us. So I don't think this will make a difference, but we can try. If we exec and try our curl command again, which is right here. No, that unfortunately does not work. So it seems like the problem here is that, like as I said, you actually have to register each service in each node or each workload into your mesh, and that has actually not happened here. Or some sort of ingress. But as I said, that has not happened here. I hope that in some way this has helped explain App Mesh a little bit to those who have had no experience with it or opportunity to use it. Overall, I'm really liking the direction with all of the Kubernetes integrations. And it's too bad that this particular demo did not go as planned. I did see, for what it's worth, that it is a few months out of date. So the newer versions of the app might have changed. I could not find a more updated demo. And so I will go ahead and get this working offline and figure out what the issue is. But I do not want to take everyone's time with too much debugging with something that I am not 100% sure what the issue is. So with that, I think I am happy to answer any questions for anyone who's watching and wants to, anyone who has any questions about App Mesh or my opinions on it. So I'll wait around in the chat for a couple of minutes for ending the stream if anyone has any questions for me. So yeah, and while that's happening, I can also just try and hack around with the configuration to see if I can get this, guy to work. So if I go ahead and check out the deployment, well, what I need is a virtual node. So let's go ahead and create a virtual node for, we don't need to be, we need backends. The virtual service names of the backends, that is, our virtual service name here is going to be color teller at mesh demo. So if I go ahead and add that, my logging is going to be dev std out, and I create a virtual node. Cool. It has no DNS host name, but it should be able to route to this. Should not need a virtual router or a service. Any questions? So let's go ahead and just give that one more try. See if we can get this to work before the time is up. Unfortunately not, but I will continue to debug on my own. As I said earlier, I hope this was helpful for everyone. Feel free to reach out to me on Twitter. My handle is my name, Eitan_Yarmish, or solo.io on Twitter. Come check out our Slack. We're always having interesting conversations about all things mesh and otherwise. So thank you so much and have a wonderful day.